Now here we have an example that is more like what we see in the homework. In this example, we're borrowing a large amount of money. $200,000 instead of 200. And we're paying it off over 240 monthly payments. That's monthly for 20 years. Instead of over 5. The reason I used 5 months in the previous examples is that I don't want to keep making a table like this for 240 months. If we wanted a table like that, we would have a computer do all the work for us. But in the homework, we're asking you to compute just like the first 3 months of the table for a loan like this one. We start out with the finance app, just like before, to figure out how much each payment should be if we want to pay off the loan in 240 equal monthly payments. So we summon up the finance app. We want to make 240 payments. Interest is still 12%. Now we're borrowing $200,000 instead of just $2,000. And I'm going to quick count my zeros and make sure I punched in enough of them, because that's an easy mistake to make. Future value is still 0. We've paid off the whole loan. Payments per year and compounds per year are still 12. And now we say alpha and enter to solve for the monthly payment, which should be $2,202.17. Again, the interest is going to be the principal times the interest rate times 1 month for each month, which again will simplify to the interest is 0.01 times the principal. All right. That means that in the first month, the interest is 0.01 times 200,000, which is $2,000. Whoa, that's almost my whole payment, right? Of the $2,202.17 I'm paying, a whole $2,000 is going toward the interest. Only $202.17 goes toward the principal. And gosh, the first few payments on these long-term loans really look like that. It's like basically everything you're paying is going toward interest, and you're just chipping away tiny little bits of the balance. After that first monthly payment, the $200,000 is only down to $199,797.83. That's barely anything. If you look at that number, you say, well, that's basically $200,000. But we keep going. Next month, our interest is 0.01 times that previous balance. So next month we have a little bit less interest, $19.97 and 98 cents, which means that a little bit more of our payment goes toward the principal. $22.02 and 17 minus $19.97 98, both very good years. $204.19 goes toward our principal now, which means that now we owe that old balance minus this principal payment, which is $199, $593.64. Okay, we still owe a ton of money, but we're chipping away at it, right? Next month, the interest is, again, the same 0.01 times the balance at the end of the previous month. So it's $1995.93. Also both pretty good years. Which means, again, we paid a little bit less interest, a little bit more goes toward the principal. So next month, $206.24 goes toward the principal, which means that what we still owe is that previous balance minus that principal payment. Now we're down to $199,387.40. And I noticed that I rounded that incorrectly. I actually wanted 1995.94 paid toward interest, which means that 206.23 was paid toward the principal, which means that we actually owed $199,387.41. Now, again, not too difficult, but definitely time-consuming and error-prone. As you just saw, it's very easy to make small errors in this process. This is a lot of why the business computer became a big thing really quickly, because you don't want to do this by hand. You don't even want to pay someone else to do this by hand. You want to have a computer do this. And of course, that's what people do in real life. What does that look like? Well, I just happen to have a spreadsheet over here. And in this spreadsheet, we can see the results of making regular payments of $202.17 on a starting balance of $200,000. And you can see that these first three rows here are the exact same as the first three rows that we found by hand. But now the computer is continuing this for the remaining months. So we don't get down under $199,000 until month 5, under $198,000 in month 10, but we get down under $197,000 in month 14. When do you figure we'll have paid off the first $100,000? That's about half the loan, right? Will it take half the time? No. It took 180 out of the 240 months. Right? We are down under $100,000 for the first time in month 180. That's 3/4 of the way through the loan that we get the first half of the money paid off. Wild, right? And now we keep going. And now we're down under 400, or under 50,000, so less than 1/4 of the amount, with what, 25 months left? So only 2 years left out of the 20 years. And then the last few months, we see the balance dropping really fast. And after the last payment, after payment 240, that didn't drop to exactly 0. Why is that? Well, remember how we got all of those awful decimals as we kept going? And we rounded all of them to the nearest cent? Yeah, that $2.77 is round-off error. The way that you do that on a real loan is you either paid $2.77 extra on the last payment, or you make one more tiny payment. Sometimes the round-off errors mean that you're a little bit under. So you might have a very small negative number there, which means that you would just pay a little bit less on your last payment. And that's fine. That happens when we round numbers. We end up with little errors accumulating over the course of 240 plus calculations. But that's very, very close to fully paying off the loan. And that's what we expect to see. That's what you would see in these tables if you kept going beyond the first 3 months. But if you know how to fill in the first 3 months, you do know how to fill in the whole table. And in real life, we have a computer do it.